obviously.
Always the algebra.
It's keeping track of the algebra, right? Like you know what you're doing, so you're tearing it off, but then you're like, dang it, there's that -2, and where did it come into play? You have to be really careful. So on these, if you can kind of take stock, and clarify at midpoints, like bring it all together, keep going. Bring it all together, keep going. Because if you try to bring it all together at the end on something where you have to use U substitution 4 times, I think, on this, is it a little challenging? So let's see here. How did people do on the first term? This first term right here. Raise your hand. How'd you do on the first term right here? How'd you do? How'd you do the x squared over 2 ln x to the 4th? Oh, we got it. I see it. Oh, we're doing pretty well. What about the next term? Negative x squared ln x cubed. What is that next? Oh, I see some coefficients. Oh, man. Oh, I see it over there. Yay. Look, I see it over there. And let's see. Can Molly keep going? Team Molly go for the win with Gandavia? Let's see here. 3/2 x squared ln x squared. Oh, look at this. Look at this. Did you guys get it over there? Boom. Did you get it? Awesome. Awesome. I like how you tiered it right there and kept track of your coefficients. Keeping track of the coefficients is challenging. Keeping track of the coefficients is challenging. So you ready to try another one? You guys like these things? No. What's the first thing you have to do if I said to integrate that by parts? What's your first choice? What's your first thing you have to choose? What do you have to commit to first? Choosing a what? A U. You have to choose a U. And the thing is, are there many different U's you could theoretically try? Sure. And I'm going to tell you there's one that will work. That'll give you an answer that you can solve. But are there other ones you could try? Run into a wall, run into a wall, run into a wall? Absolutely. Anybody want to guess what you didn't do 26 for homework, I think. Did you do 26? No. I don't think it was. Good.
It was multiple of 3.
Multiples of 3. So yeah, hopefully you didn't do 26, I hope. What's one choice for you? What could you choose for you if you wanted to? Yes, Molly. You could choose arctan. Now here's the thing. Do you remember there was 3 points, how you go about choosing U and V? You want to choose U so that you can do what to U? Take the derivative, right? And you want to choose a V prime that you can easily what? Integrate. So why did you choose arctan x squared as U? Why did you choose that?
How do we integrate?
Yeah, because either arctan x squared is going to be U or V prime. And you can't what?
Integrate.
Yeah. No. You don't want to have to integrate that, right? So you're kind of dictated what you need to choose for U. Okay, so let's see. Do I agree with you? Oh, I do. And I like writing tan inverse instead of arctan, everybody. It's just fewer letters. So I'm just telling you right now, this is what I'd like you to try. Get back to the board, find a new partner. Good. So again, I think some of you, again, a few of you got tripped up right there. There's that 1/2. Oh, you can't see it yet. So one thing you can do on this one, so yeah, you could start with just U equals tan inverse of x squared. You could simplify a little bit by doing what first? You could do U substitution first or W substitution first. So, and then when you get to something like this, what was the key? So right here, if you use substitution, this is what you end up with, this piece. What's the giveaway on that integral that tells you don't need to use parts? What's the giveaway? What's the simple structural element, Tomas?
It looks like the derivative of arctan.
Well, no, it does look like the derivative of arctan, but what's the degree of the top? 1. What's the degree of the bottom? 2. When they're off by 1, that should automatically scream at you W substitution, right? You don't need to use parts again, right? I know we're in parts, but you can do parts inside parts and W substitution inside W substitution. Now, I'm not going to make you do this now, but if you wanted to think about a generalization for this of one of the previous ones, where was it? It was, we did this work right here. No, that's arcsine. Right here for this one. I really like Sam's idea. This is just if you wanted to play around with it, I think it'd be pretty fun. Mahmoud asked, what about if we had this, ln x to the nth power dx? Because that n dictated, we're going to say n is an integer, okay? Let's make it better than integer. How about whole number? Whole number good? I think whole number is good. Because how many times on that last example did we have to do parts? I did it 4 times because it's to the 4th power, right? So as n gets bigger, you'd have to keep on doing it more and more times. You're not going to, if I asked you to the 90th, you're not going to do it 90 times. What are you going to do instead? You're going to try to figure out what the general not what the general form is for each term, and use ellipses. You'd write out the first 3 like it was a geometric series or some sort of general form. It'd be something cool to think about. But I like this idea. Like, what would happen if you raised it to the nth power? So one question down here. This is a really interesting one right here. ln t squared. The simplest ones to write can sometimes be the most challenging to solve. The simplest ones to write can be the most challenging to solve. So here's a video of it made by...
Okay, so this is number 25 from the Chapter 7 review, and I picked it because after I decided that it was completely impossible,